with a quadratic in standard form, we need to common factor the a value out. So we get x squared. Now, what do we have with the b value? B will be divided by a factor of a. And so you can see if we were to distribute the a back into the parentheses, we'd get our ax squared. And for the second term, the a's would cancel, and we would be left with bx, as we had before. Next thing to do is to add and subtract the same value. And so what do we choose to add and subtract? Well, we take it from this middle term. And we have an equation for this. We divide the middle term, b over a, by 2. So that'll give us b over 2a. And square it. Squaring it will give us b squared over 4a squared. So this is what we add and subtract. Next, we want to move this term that we don't use outside of the brackets, multiplying by the term in front. So multiplying by a factor of a. Multiplying by a factor of a, we can see maybe that one of the degrees of a would cancel. So we'd be left with just 1a in the denominator. Now it's where we want to get our equation into its perfect square form. So remember, when we have some binomial squared, should recognize that form. So we want to try to get there. How do we do this? We can get this by just dividing the middle term by 2. And we've done that already. We have b over 2a. That's done. That's come from dividing the middle term by 2 already. And that's always what we put in the brackets here. B over 2a squared. Don't forget to square the binomial because it's a perfect square now. So this is actually really interesting because this gives us a general formula for the x and y values of any vertex, this x and y value right here. So the x of any vertex equals negative b over 2a, because remember we have to switch this sign. So this is a useful formula, and we actually use this quite a bit. And the lesser used formula comes from everything in behind, which would be the equation for the y value of the vertex. Not sure why we don't see this as often. It's just as useful for finding the maximum height or the minimum height. So this will give us the y value of our vertex.